Hello, today our assignment is day number 2 of solving linear equations at the bottom of the home page, September 24th, if you're watching the video, but it may be a different date. It's going to be day 2, solving linear equations. So let's go ahead and open that. Okay, so you're watching the video right now, so you already opened that. These are the solving steps that you saw on day 1. So I'm going to go ahead and open them real quick, and we're going to refer to those. Okay, so these are the solving steps that you can use as you're doing the assignment. And remember, if you need a translation, you can click on this link to translate this document so that you can see it in your language. Okay, and then this is the assignment right here, so you can open that one as well. Okay, I've opened mine in Kami, so make sure you open it in Kami so that you can mark it up and make notes and use it. And of course, when you're done, you're going to put your answers here in Canvas. All right, so today we only really have 2 new types of questions, questions 1 and 2, and then there'll be some practice questions. And then when you're done, there's some review questions, so that there will be 14 questions. So the review questions are going to be like the ones you saw yesterday. So I'm not going to show you how to do those. I'll let you try those, but you can ask me for help in class or later if you need it. But we're going to focus on questions 1 and 2 today. These are the new questions, okay? So make sure that you look at the translation of this if you need to, what this is saying right here. But if you do, the important thing to know is that we're looking for an equation that's equivalent to another equation, which is this one right here. So let me give you an example of what that means. It means when it's equivalent, it means that it's the same equation, but you've just moved things around. So let me give you a very simple example. Okay, so let me give you an example. Like say we have this equation right here, 3x plus 5 equals 11. And let's say I wanted to solve it. What's the first thing I would do? You probably remember I would subtract 5 from both sides to combine like terms on opposite sides. And then I would get a new equation, right? So my 5's would cancel out, and I'd have 3x equals 11 minus 5 is 6. Now, if I kept going, what would I do? I would divide by 3. Let me do it in red so you see it. I would divide by 3, right? And this would cancel, and I get x is equal to 2, correct? That's from this equation, okay? Now, so we know that's the correct answer, right? But is it correct for both equations? Well, if I take this 2 and I put it right there, I get 3 times 2 is equal to 6. So that's 6 equals 6, yes. So that means 2 is a solution for this equation right here, equation number 2. And if I also put it right here, 2 right there, I'd have 3 times 2 plus 5. Is that equal to 11? Well, this would be 6 plus 5. This would be 11. So yes, 11 is equal to 11. And I end up having another equation where the solution is 2 in the second equation and the first equation. Why is it? Because these two equations right here, even though they look different, are equivalent. Are equivalent equations. Equivalent. Because as long as you do something to one side of the equation, to both sides, the same thing to both sides, you're going to end up creating a new equation that looks different, but it's actually the same equation and it will have the same solution. So that's what you look for when you try to figure that out. So now let's go to the assignment. Okay, so let's look at the original equation. So we've got an equation right here, and then one of these is equivalent to it. Well, for one thing, this has 4 terms. So usually what happens is if these only have 2 terms, probably there's been some simplification. Well, let's look to see if we can understand what simplification is. If you look at each one, there's only one x term in every single one. So clearly, well, here there's 2. So maybe there's 2 terms. So what looks like they maybe did is they combined equations, right? Or like terms, sorry, like terms. Now, so I'm going to combine the 6x and the 3x, but remember they're on opposite sides. So if we go to our solving steps and we combine like terms on the opposite side, that would be step number 3. We have to use the opposite operation to remove a term from one of the sides. And we have to make sure to do the same thing to both sides. So like when we have this equation right here, we combine this, the 5x and the 3x, but they were on different sides of the equation. So we subtracted the 3x and this went away, but we had to subtract it from here. So 5x minus 3x. So that means I'm going to subtract this 3x right here to get rid of this, but I have to subtract it from here. So what do I get? 6x minus 3x is 3x minus 3. This goes away, and then it equals 10. Okay, so the first thing I'm going to do is I'm going to look at my equations to see if anything matches that. I have 3x minus 3 over here, but I don't have it over here. So maybe they did another step. Maybe they went ahead and they combined, let me do the pink, the numbers, the constants. So they're on opposite sides. So now what I'm going to do is I'm going to combine them. But I look at the constants and let's see what we can do. Well, maybe I go plus 3. And if I do plus 3 to both sides, this goes away. So I'll do plus 3. Sorry, over here, plus 3. And what do I get? I get 3x, this goes away, equals 13. Does this match anything? It matches A. This is close, but it's not 13x. It's just only 13, right? It doesn't have an x. So that's not that one. It's not 9x. Okay, so that's how you do it, okay? So that's how you do question number 1. And so there's that. Okay, the next kind of question we have is this one here. Okay, so for question number 2, we're being asked, we've got this equation right here, right? And we're being asked to solve for x, which we normally do, right? But the answers are not numbers. They're expressions with variables and a number. They're not a number like like we're used to. Okay, well, I want you to read this and make sure you translate it. And we're going to go through this process, and I'm going to show you an example, okay? So let's go to this. So if we have 3x equals, let's make it equals 12, right? If we solve this equation, what would we do? We would divide by 3, and we would get this x equals 4, and we would have a number, right? But what happens if we had something like this? Rx equals 12, and we're supposed to solve for x. Well, same thing. When you solve for x, it means you get x equals by itself or alone, right? On one side of the equation. That's what it means. But right now, there's an r there, so we need to remove the r. It's being multiplied by the x, so we would have to divide. Just like we divided by 3, we'd have to divide by r to both sides. This would cancel out, and we would get x is equal to 12 over r. It's not a number, but it is an expression that represents what the solution is. So they call that solving for x in terms of r. Okay, so now let's apply that to this problem over here. Let me rewrite this, y equals 3x plus b. Okay, so the first step is to isolate x, which is our goal, is to remove things that are being added or subtracted to it. Okay, so we're going to go in the reverse order of operations. We're going to go what's being added or subtracted. So I want to remove the b so x can be by itself or alone. So I'm going to do the opposite of plus, which is minus, to both sides. Okay, and so when I do that, I get y minus b equals 3x. And then I want to divide by 3 to remove this, so I got to divide the whole other side by 3. So now I get x, okay? What's the answer? Y minus b divided by 3. Now, another way to write this, you don't see that over here, right? It looks like you got parentheses. So another way to write that is kind of like this. I'll write it over here, y minus b, put it in parentheses, meaning that I'm going to divide it by 3. This means that this whole thing is divided by 3, not just the b. So y minus b divided by 3 is c, okay? So that's how you do these kind of problems. The next questions are practice questions that you, for the 2 questions that we just did, same kind of questions, which is equivalent, and solve for r. This time we don't always have to solve for x, we can solve for r, but the point is we want to isolate r. We're going to have something that is r is equal to one of these answer choices. After that, you're going to do some review questions that were like the ones you saw in the last lesson. So that's going to be 3 through 7. We're going to do some more review of these, equivalent, and solving for t, and then a few more practice questions. So when you're done, make sure you come and you put your answers in Canvas.